Alright, today we're going to be talking about using function notation. Before we get into using function notation, we need to understand why we use it. So function notation is another way to name a function. Alright, so before we get into how we read it and what it means, let me give you 3 examples. Let's say I have a function of y equals 3x plus 1, y equals negative 2x minus 2, and y equals 5x minus 1. Okay, so we have 3 functions. The reason we use function notation is we don't want to use always the y. Okay, the y right here, because it doesn't tell us, all it says is y and another y and another y. So if I want to talk about more than one equation, then function notation works. That way we're not getting confused on which function I'm talking about. So it's another way to name a function. Instead of writing y equals 3x plus 1, I can write this as f. I'm going to put an x inside of parentheses and then 3x plus 1. Okay? Now, the way we name this is called f of x. X represents our input. Since x is our input, our domain, that's the one that is in the function itself, that's the letter we're going to use, f of x. Now let's say the second equation, I don't want to call it f, let's use another letter, so I'll use g. So g, and then put an x, and this will be represented as 2x minus 2. So this can be g of x. Why x? Because x is our input. The last one, instead of using y, I'll use h. H with an x inside, and then this would be 5x minus 1. Or you can write it, you can call it h of x. So this is the way we write functions other than using y. The very simple answer as to why we use function notation is we don't want to confuse anybody as to what we're trying to communicate. So instead of saying y, I can say f of x, g of x, h of x. So I know you're talking about, for f of x, I know it's 3x plus 1. For g of x, I know it means negative 2x minus 2. H of x, I know it's 5x minus 1. So I can have 20 functions, and I can just say, oh, I'm talking about function a. So you know it's going to be a of x. Oh, I'm talking about function z, z of x. Now, does it always have to be x? Not always. The x, again, represents the input. So let's say I have an equation where we're using height and time. Okay, so instead of using y and x, I'll use h equals 3t minus 1. Let's say I have that. So let's say t represents time and h represents height. So I could write this as h of t. T is my input. That's where I get the t from. And that's going to equal to 3t minus 1. So our input is our t. This is known as h of t. So that's the reason we use function notation. So on the function notation concept summary, they replace the y with f of x. It reads as f of x. The f is the name of the function. So we use it so that we don't have to use the same letter, y, over and over and over again. I can have many functions, and if I name them individually with different letters, then it's a lot easier to understand. And that's the reason we use function notation. For problem 1, we're going to evaluate a function. So this is relating to reading. The function wx, or w of x, equals 250x represents the number of words w of x. So first thing is we know that words is going to represent w of x. So we'll write down that w of x, that would represent words. And you can read in x minutes. So our input, which is our x, we'll write it here. X is going to represent the number of minutes. Now, how many words can you read in 8 minutes? Since minutes is x, they're telling us that x is 8. So now, all we need to do is plug in for x 8. So W of x equals 250 times x. Now we're going to replace the value of 8 into the x. So we're going to plug this value into the x here and to here. W, and for x, we're going to plug in the 8. Okay, so this means W for 8, or W of 8, because 8 is our x. That's going to equal to 250, and x is 8 minutes, so we're going to plug in 8. W of 8 equals 250 times 8. 250 times 8 is going to equal to 2,000. So therefore, the number of words, is 2,000 for 8 minutes. And there's our answer to problem number 1. So remember, key things. Whatever our input is, we're going to plug it in for the x, and then what goes inside of that function, which is based on our input, which is 8, which is the number of minutes. So it would be W of 8 and then our answer. Okay, let's move on to problem number 2. For problem 2, we're going to find the domain and range of a function. In this case, we're going to use f of x or anything else they give us other than just y. So the domain of f of x equals negative 1.5x plus 4 is 1, 2, 3, 4. So they're telling us that our domain is 1, 2, 3, and 4. What is our domain? Our domain are our x values. So that in this case, the x values is the input, which is our x right here. So we're going to plug in the values of 1, 2, 3, and 4 for the x. So same thing how we did problem number 1. We're going to say f, and then instead of an x, we're going to plug in the value of 1. F of 1. And then that's going to equal to negative 1.5 times x, which is going to be our 1, plus 4. So if we plug this in, our answer is going to be 2.5. Now we're going to go ahead and plug in 2. So f, and now we're going to plug in 2. That is going to equal to negative 1.5 times 2. Negative 1.5 times 2 is negative 3. Plus 4, or negative 3 plus 4, is going to give us 1. Our next one is f of, and we're going to plug in now the 3. F of 3 equals negative 1.5, and we're going to plug in the 3. And then we're going to add the 4. Negative 1.5 times 3 is negative 4.5 plus 4 is going to give us negative 0.5. The last one, f of 4. We're going to plug in 4. So that's going to equal to negative 1.5 times 4, which is negative 6, plus 4. Negative 6 plus 4 is a negative 2. Now the question says, what is going to be our range? So our range is going to be these values right here. The way we want to write that is we're going to say range is, and then we're going to put a little bracket, and we want to put these numbers from least to greatest. So our answers are negative 2, that's the least, negative 0.5, 1, and then 2.5. And there's our answer to problem A. For problem B, the range of f of x is 3x of fx equals 3x is 0, 3, 6, and 9. What is the domain? So what they've done is now they're giving us the range and they want the domain. So what we're going to do is we're going to write down our range. Our range that is given to us, our range is 0, 3, 6, and 9. Well, our range are our y values, or the output, but we're not going to use y values. This really means it's our f of x. Okay, so we're going to substitute our f of x for 0, 3, 6, and 9. This is our new y value, which is f of x. So we're going to plug in 0. So let me write these equations down. I get 0 is going to equal to 3x equals to 3x. Now I want to solve for this. So I'm going to go ahead and divide both sides by 3 and solve for our domain. 0 divided by 3, and we're going to get x equals 0. So there's our first answer. The next one is going to be 3. We're going to plug in 3 for f of x, which is our y value. So we're going to say 3 equals 3 times x. Divide both sides by 3, and x equals 1. There's our next domain. Now we're going to plug in 6 for f of x. 6 equals 3x. Again, please understand what's happening. I am plugging in the 0 for f of x, the 3 for f of x, and now I'm doing it for the 6 for f of x. So now, divide both sides by 3 and solve for x. So x equals 2. The last one is to plug the 9. So again, we're going to plug that 9 for f of x. So we have 9 equals 3x. Divide by 3 on both sides. And x equals 3. So there are our 4 values, or our domain. So we're going to write down domain is, open bracket, go from least to greatest, 0, 1, 2, 3. Close bracket. There's our domain. Domain is all our x values. So there are our answers for the x. This is the last problem for this unit. Finish up your summary, and then we'll see you guys tomorrow if you have any questions. Okay? All right.